Definitions. Mass is the quantity of matter a body contains, the units being in kilograms. Velocity is the measure of the rate of movement of an object in a given direction, in meters per second. Acceleration is in meters per second per second. Inertia is an inherent property of matter whereby it continues in its existing state of rest or uniform motion in a straight line. Momentum is a unit of measurement, and it is the quantity of motion of a moving body measured as a product of its mass and velocity. Force is an influence tending to change the motion of a body, or producing motion or stress in a stationary body, with units being the Newton, kilogram meters per second squared. Newton's laws. Newton's first law of motion states that a body at rest will remain at rest and a moving body will continue to move at the same speed in the same direction. Newton's second law of motion of a body states that in order to change the state of a body at rest or moving in a straight line at a constant speed, a force must be exerted upon it. And that force is a product of mass and acceleration. Newton's third law of motion states for every action there is an equal and opposite reaction. The international system of units are base units for kilograms for mass, meters for distance, seconds for time, amongst others. Temperature. Temperatures are measured in degrees Celsius or Kelvin when measured relative to absolute zero. 0 degrees Celsius is equivalent to 273 Kelvin. A temperature change of 1 degree Celsius is the same as a change of 1 Kelvin. It is just the starting or 0 point which is different. The degree symbol is not used when temperatures are displayed in Kelvin. Force. Forces and hence weights are measured in newtons. To convert masses in kilograms to newtons, multiply by the gravity constant 9.81 meters per second squared. For example, 1 kilogram equals 9.81 newtons. 10 kilograms therefore equals 98.1 newtons, and 75 kilograms equals 735.75 newtons. Static pressure. The static pressure of the air at any altitude results from the mass of air above that level. Due to its mass, the tall, approximately 100 kilometre column of air above us creates a very high pressure in all directions on everything beneath it. At sea level, the force due to the pressure of the column of air is approximately 100,000 newtons per square metre, and only a slight relative difference in pressure around the aircraft wings is needed to lift a very heavy aircraft. A pressure difference of only 1% gives a pressure difference of 1,000 newtons per square metres. The reduction of pressure caused by increased altitude causes a reduced force at a given pressure difference over a surface. A 1% difference at 20,000 feet produces a pressure difference of 500 newtons per square metre instead of the 1,000 newtons per square metre at sea level. So the possibility to fly by using wings becomes limited at high altitudes. Speed, drag and heat. When air flows around a moving body, it produces a rearwards force called drag, which increases rapidly with speed. The density of air causes friction between the body and the air, and that produces a limit on the maximum speed. Friction also causes heating of the body, which can affect airframe strength. So the flight envelope in which an aircraft can fly is therefore limited by altitude and speed. Fluids. A fluid is a substance that possesses the property of flowing freely and does not have a definite shape, but tends to conform to the outline of its container. Fluids can be classified as liquids or gases. Liquids occupy a definite volume, independent of the volume in which they are contained. Gases expand to fill the entire volume of the container in which they are placed. In other words, you can half fill a bottle and the liquid will occupy the bottom half. If a gas were to be placed in the bottle instead, it would occupy the entire volume of the bottle. Fluid flow and viscosity. Fluids behave differently when they are flowing. Heavy oil takes a longer time to flow and fill a vessel than water does. The different behaviour of fluids is due to the different internal friction created between the layers of the fluid when it is in motion. This is called viscosity. Pascal's law. In a fluid at rest, the pressure at each point acts in all directions at the same time. Molecules exert a force on surfaces that they are in contact with. The ratio between applied force, perpendicular, that's right angles, to the surface, and the surface area is called pressure. Pressure equals force over area, and the units are newtons per metre squared. Static pressure, P. The static pressure of the atmosphere is caused by the weight of the air acting on a surface, acting equally in all directions. Dynamic pressure, Q. Dynamic pressure equals half rho v squared, where rho is air density and v is the relative speed.